Opening with a murmur and ending with a bang, the Permian saw the rise of advanced synapsids. In the oceans, ray-finned fish continued to diversify, while terrestrial vertebrates evolved a new type of predator, the cynodont. Meanwhile, herbivores were perfecting sophisticated chewing mechanisms. The rise of advanced synapsids, mammal-like reptiles, was the most important evolutionary event of the Permian, because it was critical to the emergence of mammals and, ultimately, modern humans. As the Permian progressed, the terrestrial fauna took on a more familiar setup, with relatively few predators feeding on the more numerous herbivores. The top predators of the late Carboniferous were sprawling in posture, demonstrating a less active mode of life, similar to many modern reptiles. By the late Permian, synapsid predators had evolved features that enabled active hunting. Their limbs had elongated and were placed more directly under the body. Their teeth had differentiated into incisors, canines, and cheek teeth, and their eyes had moved farther forward, improving stereoscopic vision. These early cynodonts had nearly all the characteristics of mammals. Nowhere is the evolution of mammalness more clear than in the middle ear. Mammals have 3 middle ear bones, the malleus, incus, and stapes. All other tetrapods have only the stapes. The fossil record of synapsids shows how these 2 extra bones, once part of the jaw articulation, were freed from their jaw bracing function to become integrated into the middle ear region, where they form part of the sound detecting apparatus used in hearing. The Permian ended with the greatest mass extinction of all, with an estimated 95% of all marine and 70% of terrestrial species dying out after volcanic eruptions poisoned the oceans and atmosphere. Xenacanth sharks have been described mostly on the basis of isolated tooth found in marine and freshwater rocks from all over the world. As in all other shark groups, 2 pairs of fins projected from the belly region, the pectoral fins closest to the head, and the pelvic fins closest to the tail. These acted as hydrofoils, lifting the shark as it moved through the water. The male had a pair of rod-like claspers projecting backward from the pelvic fins, used to deposit sperm directly into the female's body during mating. The final fin on the underside of Xenacanthus was the anal fin, which was divided into 2 parts. Its tail was completely in line with the rest of the body and the upper and lower lobes were about the same size. Archaeops is one of the best known of the temnospondyl amphibians. A large number of specimens have been collected, and because the animal was large and robust, these specimens are remarkably well preserved. Archaeops was also unusual among early amphibians in that the entire skeleton was ossified, made from bone, which is far more readily fossilized. Its contemporaries had more cartilage in their skeletons, and because these were not mineralized, their complete anatomy has not survived. Archaeops first appeared in the late Carboniferous of North America, but most specimens that have been found come from the early Permian. Archaeops was one of the top predators in its ecosystem. It resembled a short, fat alligator and almost certainly fed on fish and small amphibians. The long rectangular muzzle is the basis of its name, which means drawn-out face. Archaeops probably underwent a change of diet during the Permian. Early specimens have a muzzle shaped like a rounded shovel with small, almost marginal teeth suitable for seizing small fish. However, later Archaeops, including the one shown here, had a longer, more rectangular snout with clumps of larger teeth at intervals, much like those found in modern crocodiles, which feed on larger animals caught at waterholes and in rivers. Simoria was a small carnivore that, for many years, was considered to be close to the amphibian-reptile transition. There was much debate as to whether it was a reptile or not until paleontologists noticed that its smaller relative, Discosauruscus, had external gills and lateral line canals in its juvenile stage. This pointed to Simoria being pre-reptile, and it is now considered to be a primitive amphibian tetrapod that paralleled reptiles in some of its adaptations to terrestrial life. Diplocaulus is one of the most common fossils found in the Texas red beds, but it has no living relatives. From the neck backward, it resembles a fat salamander, but its skull is a strange boomerang shape, with long, flattened horns on each side. One idea is that these horns acted like hydrofoils by using them to manipulate the water current. Diplocaulus could gain lift or downward thrust, which enabled it to rise and sink with little effort.
Scutosaurus was a large herbivore belonging to the Parasaur group. All parasaurs had long, thick ribs forming a barrel-shaped chest. The large torso contained an extensive digestive tract to break down tough plant material. Blunt teeth were capable of cropping vegetation, not chewing it. Its skull was broad and flat, and short, down-pointing tusks hung from its lower jaw and the sides of its face.
Moschops was a thick-skulled herbivore with stout legs and thick ribs that formed a large, barrel-shaped chest. It had a very large gut for digesting tough plant matter. Overall, Moschops was a heavily built animal, and full-grown adults probably had little to fear from the predators of the day. The Dinocephalians, which included Moschops, were one of the earliest therapsid groups to evolve and were very common in the first part of the late Permian. They diversified to exploit many of the ecological roles formerly carried out by pelycosaurs. Carnivorous and herbivorous Dinocephalians are known, but all of them have peculiar front teeth. Unlike those of other animals, the upper incisors do not overlap the lower incisors, but interlock with them, allowing effective nipping. Adaphosaurus was a herbivorous pelycosaur with numerous blunt teeth that formed crushing plates. The teeth were not just around the jaws but also on the roof of the mouth and sides of the lower jawbone. Although it was herbivorous, Adaphosaurus was not related to Cotylarhynchus. One of the most distinctive features of Adaphosaurus is the sail crest on its back. Unlike the sail of Dimetrodon, small prongs branched off from the main rods that supported the sail, giving them the appearance of twigs. Despite this difference, the sails of Dimetrodon and Adaphosaurus probably evolved for the same purpose, trapping heat while basking. This meant that Adaphosaurus could warm its body quickly in the morning sun and become active before many predators. Dimetrodon is often included in dinosaur books, and thus commonly mistaken for a dinosaur. It is an early synapsid, and in fact more closely related to mammals, with which it shares some anatomical features, such as a single hole in the skull behind the eye. It lived in the early Permian, at least 40 million years before the first dinosaurs, and lacks dinosaur features, such as upright legs. Dimetrodon was among the largest carnivorous pelycosaurs and was the most fearsome predator of its time. Its high skull and relatively short snout gave it a powerful bite. Dimetrodon means two-sized tooth and refers to the two sizes of teeth in the jaw. The two canine-like fangs in the upper jaw were roughly located in the position of canine teeth of modern mammals, such as dogs and humans, and their roots extended through the bone all the way up the side of the face. Although they are not as striking as the saber teeth of big cats, they were powerful and deadly. In all, Dimetrodon had 80 large, pointed teeth, which show that it was specialized for killing other large land vertebrates.